Welcome. This is Math 2, lesson 423. We're going to be talking about inverse trig and how to do it. So, as of now, we know how to do different things. I'm going to go ahead and zoom in on this picture. Let's see what we can do. And let's straighten it up. All that good stuff. There's no straight because the angle's bad, but that's okay. We'll do our best. All right. So, our enduring understandings. We now know how to solve for missing sides in any right triangle, give a acute angle and the length of any side. What if we want to determine the angle is our question. If we're given two lengths of two sides of a right triangle, can we work backwards to determine the unknown measurement? So the goal here is to work backwards to determine the angle. So we're going to get into this part here. But for now, let's just kind of continue to focus on Mr. Gao and what he's trying to do. So Mr. Gao is to build a wheelchair ramp for the school's auditorium. The ramp must rise a total of 3 feet in order to get from the ground to the building. So there's the ground to the building, that step is 3 feet, meaning there's stairs somewhere, but now he's trying to build a wheelchair access ramp because people can't use the stairs. So in order to follow state building code, the angle formed by the ramp cannot exceed 4.76 degrees. Otherwise, it's too steep and it's hard for wheelchairs to use. Okay, Mr. Gao has plans from the planning department to call for the ramp to start 5 feet away from the building. Will this ramp meet the code? So what we know is that this is 3 feet tall. Draw an appropriate diagram. So basically this is the building and I've got this 3 feet. The stairs go up 3 feet. And they told me that they want to do 25 feet away. And we're trying to find this angle right here, which we'll call theta. And he needs to know the angle. Which in this case is theta. Okay. And so add all the measurements we can. What does he need to know? So this is all I know. I don't know how long the ramp is, but I know that it's going to be 25 feet away from the building. That's the plan. And my goal is to figure out if it's too steep because I cannot exceed that angle. So let me mark that number as being really, really, really important. I know we've got it bolded and all that stuff, but I'm going to go ahead and put a red box around it. Cannot exceed this angle. Okay. To determine angle from a trigonometric ratio, we need to undo it. Just like you can do addition with subtraction and multiplication with division or squaring by taking the square root, these are all pairs of inverse operations. So every operation has its inverse pair. It's really important that we understand that. We use that on a regular basis. Every operation has its inverse pair. I like pairs. Okay, return to our diagram. According to the plan, what will angle ramp be and will the ramp be to code? So we would set up tangent of theta equals 3 over 25. Okay, and I'm going to go ahead and see how bad the decimal is for 3 over 25. Using a calculator, just simple calculator on my phone. 3 divided by 25. Oh, that's not bad. So it's a nice clean decimal, so we'll go ahead and use that, which is 0.12. Because you know I'm a big fan of fractions, but when I'm dealing with story problems, I tend to go into decimals because it's going to work better for what I'm doing. So I still have this. And now I'm going to take the tangent inverse of both sides. And so we write that as tangent inverse of tangent of theta. We hardly ever write that down, but we'll do it today. Equals tangent inverse of 0.2. Because whenever I do to one side, I must do to the other. Okay. So this tangent inverse undoes tangent, so we're left with theta equals the tangent inverse of 0.2. So I've got my calculator here. And how do I get to tangent inverse? So this is the Desmos calculator, and there is no shift or second, but if I click function, tangent inverse is right underneath tangent. And I want to leave this space because I don't want to put it right there. Anyway, we'll just leave. Okay, so tangent inverse of 0.25. 0.12, excuse me. And so there's my answer. So theta equals 6 point. Wow, that's blurry. 6.8427 dot, or about 6.843 degrees. So that's an about. Will the ramp be to code? That's the question that we have marked in red or at the beginning. Will the ramp be to code? So if we go back and we look, cannot exceed 4. What does exceed mean? Exceed means be bigger than. So we cannot exceed 4.8. Are we exceeding that? We absolutely are. Bigger than was faster to write theta than write that angle. Okay, so theta is bigger. So now here's the next question. How far must the building ramp be in order to meet the building code? If Mr. Gao builds the ramp exactly to code, how long will the ramp be? So all work. So it's the same idea. We've got the same triangle. I know that this is 3 feet. I don't know this. This is what I'm trying to figure out now. But I'm going to build exactly to code. So I'm going to use this angle, the exact code angle, 4.76. Okay, so I'm using that exact angle and building exactly to code. So I'm going to go ahead and set up tangent of 4.76 equals opposite over adjacent. So x times the tangent of 4.76 degrees equals 3. So x equals 3 divided by the tangent of 4.76 degrees. Then normally this answer is awesome, but we are doing a story problem and we want to know how long to build our ramp. So I use my calculator. I'm going to have 3 divided by tangent of 4.76. And according to my calculator, which of course makes everything blurry, the joy of backlighting, it's going to be 36.027 66608. Okay, and that is feet. So they were over 10 feet shy of the right length. This is going to be really, really long. A lot of times we try to put up a quick ramp and we don't stick. That's why there are building codes, is because it's too steep for somebody to manipulate a wheelchair up. They're going to roll back down, stuff like that. So it actually has to be very, very long, which is why you'll see, because 36, that's really, really long. That's six feet tall people. So just something to keep. All right, so with that in mind, now let's just practice. There's our story problem with the context, all that stuff. Let's just jump into the practice. That's not what I wanted to do. That's what I do. Okay. For the following triangle, determine all missing angle measurements. So, all missing angle measurements. Not just some, all. Let's start with this one. And we'll use green down here. So if this is my missing angle, I'm going to be using sine of theta equals 3/6, which is 1/2. Okay. I know all my missing angle measurements. You don't. So I take the sine inverse of 1/2. So I grab my calculator, return sine inverse, again for me on this one is function, and then sine inverse of 1/2. And so there you go, 30 degrees. And I'll be right back. Okay, so theta is 30, and since theta is 30, we find our other angle is 60. And so it wouldn't have mattered which one I started with, but I started with this one because we don't know that the sine of 30 degrees is 1/2, as well as we know that the cosine of 60 degrees is 1/2. So I wanted to do that backwards on purpose. So find all the missing angles. So 6 and 8, this one is tangent. Doesn't matter which one I do though. So I'm going to go ahead and make it a proper fraction. So I'll use theta down here. So tangent theta equals 6 divided by 8, which is 3/4. So theta is equal to the tangent inverse of 0.75 because it takes up less room than 3/4. Then I grab my calculator. Oops, that's not my calculator. And so tangent inverse, again functions, tangent inverse of 0.75. And there we go, 36.8698. Theta equals 36.87. I want 3 decimal places. But that is 3 decimal places, 70, because it rounds up. So anyway, 870. Then I'm going to find my other angle. It's not as easy as this one because it's not clean, but it will be 90 minus the answer I just got. And that's what A and S means. So minus the answer I just got. So I just pushed A and S, and that's what populated on the calculator. And so my other angle up here, I'll use purple for that one, or blue. The other angle up here is 53.130. And those two angles should add up to 90. Okay, let's see what you can do with C on your own. Decide what to set up, sine, cosine, or tangent. That's the first question. Oh, actually pick an angle. So let's all pick the same angle. I'm sorry. I'll pick the same angle. So we're going to, since we've always chosen the angle down here, that's what we're going to choose again. But if you really want to choose the other one, that's cool. But in this case, we picked this angle. Now, sine, cosine, or tangent. Decide. Well, it can't be tangent because I know the hypotenuse, so it's not tangent. Since I have my adjacent side, this is cosine of theta equals adjacent over hypotenuse, which is 1/2. So the cosine of theta is equal to 1/2. Means that theta, unless you know automatically cosine is 1/2, 60 degrees, cosine inverse of 1/2 is, again, I'm using my calculator, function cosine inverse of 1/2 is 60, which again I already knew. Making my other angle 30 degrees. And that's that. Questions? Ask in class. Let's see what's next. So just have a reminder of what everything is again at the top. Note none of these triangles are drawn to scale. Write and solve an equation to determine the missing angle. So and then what is the third angle? I don't know if we'll actually need that. I think that's left over. Let's just find the missing angle. So sine, cosine, or tangent. Cosine. Adjacent over hypotenuse. Oh, hey, I got 1/2 again. What is it? 1/2 is associated with 30 and 60, right? So which one do you think it is? 30 or 60? It's 60 degrees. Let's check and make sure the calculator bears me out there. I just did that. You think I would remember from 5 seconds ago. Cosine of 1/2 is 60. So that's 60. Next problem. Not drawn to scale, but these are both 8. This is sine, cosine, or tangent. It will be tangent. Theta equals 8 over 8, or 1. What is the answer? And again, this one I recognized too, and I knew right away what the answer was. I didn't have to do any of this. But I'm going to take the tangent inverse of 1, which gives me theta equals 45 degrees. All right. Question mark, or theta. Put theta in all the rest. Sine, cosine, or tangent, that's what you're deciding. I'm going to use sine. Sine inverse of 8 over 19. This one I do not recognize. I have no idea what it's going to be. Don't forget to do sine inverse. Calculator. Return function. Sine inverse of 8 over 19. And so theta equals 24.901. And again, I like 3 decimals. That's true forever. And if I say accurate to 3 decimals and you put a whole number and it was a whole number, you're all set. Perfect, perfect. So sine, cosine, or tangent. This is cosine. So cosine of theta equals adjacent over hypotenuse. It is easier if I simplify first. Whoops. One of the cool things about my calculator, I think, I'm not sure, I haven't actually tried this on this version. Let's see, 34 divided by 38. And notice right here, whoa, blur, 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 blur. Right here, there's a fraction button. Fraction button right there. If I click that, it will give me a fraction answer, and so I don't have to think about it as hard. And 17 over 19 might be easier to write. So I have theta is equal to the cosine inverse of 17 over 19, which again is 34 over 38 simplified. I divided them both by 2. Okay. And so theta equals so I'm going to take the function cosine inverse of the answer, I just had. And I get 26.525. Okay. 2 left. Sine, cosine, or tangent? Yes, this is tangent. Is equal to opposite over adjacent. And 4 over 16 is 1/4. So theta is equal to tangent inverse of 1/4. Calculator. $14.036. Okay. And last but not least, sine, cosine, or tangent. Yes, this is sine of theta equals 35 over 36, which cannot be simplified. So theta equals sine inverse of 35 over 36. So theta is approximately equal to sine inverse, sine inverse of 35 over 36, which is 76.464, rounding up. Okay, good luck. I hope this was helpful and helps you feel a little bit more confident when doing inverse operations to find the angles, which will require inverse operations, and we'll talk again soon.